The first attack I'm going to go over is a TCP flooding attack. The goal of this attack is to flood the server with SYN packets to prevent the user from being able to telnet into the server. So first, I'm going to go onto the server machine and turn off the countermeasure on the server by typing in the following command that you see me typing here. I'm setting the SYN cookies equal to 0 because when the SYN cookies are turned on, they will kick in and the machine detects an attack and therefore deader the attack. So by setting the SYN cookies equal to 0, the SYN cookies will be turned off and it will allow the attack to be successful. So now that I have the SYN cookie set to 0, I'm going to go to the client machine, and here I'm going to telnet into the server, which is 10.0.2.6. And so here I am logging in. And the username is going to be seed, and the password is going to be D's. So now that I'm telnet from the client to the server, I'm going to go back to the server and run the netstack command. So this command is going to show me all of the half-open connections before launching the attack. So we can see here that most of the TCP states are listen, which means it's waiting for a TCP connection, and then we have one established connection, which means there's a three-way handshake that was completed. So now I'm going to go to the attacker machine to actually launch the attack. So I'm going to type in the following netwalks command against the server's IP address, which is 10.0.2.6, along with port 23, which is targeting the telnet server. So now that the attack is running, I'm going to go back to the server to type in the netstack command again so I can compare it to the results we saw before the attack. So you can already see that there are many SYN receive states, which means that the server is being flooded with these packets of half-open connections and many different random IP addresses. So when I type in the top command, you can also see that the CPU usage is not high, so it's still able to perform functions, but it cannot accept telnet connections. So now when I go back to the client and I exit and try to log back in, it just says trying to connect, and it doesn't actually connect because the server cannot accept any telnet connections. So now we can see that the SYN flooding attack was successful. I'm going to close the attack and I'm going to show you what happens when I turn SYN cookies equal to 1, meaning I turn the SYN cookies on. So I'm going to cancel the attack here, and then close everything out so I can restart. So I'm going to start back onto the server machine, and I'm going to set the SYN cookies equal to 1 this time so they're turned on. So now I'm going to go back to the client over here, and I'm going to telnet into the server again at 10.0.2.6, and then again logging in with the username seed and password D's. So now if I go back to the server and type in the netstack command again, we're still going to see all of those SYN received packets from the previous attack, but once we run this command, we'll see that there aren't any more coming in since the attack was stopped. So all those SYN packets we see there are from the previous attack. But at the bottom you can see there was just listening because the attack isn't going on anymore. So now I'm going to go back to the attacker and launch the attack again. So once I finish typing in this command, I'm going to go back over to the server and type in the netstack command again. Alright, so back at the server. So we can see that nothing really changed, it wasn't being flooded, and now when we exit on the client side and try to log back in, we're able to log in just like normal, no error, it doesn't stuck trying because the sync cookies were turned to on. So now you can see the difference between when the sync cookies are turned on and when they're turned off. Successful SYN flooding attack, I'm going to show you the next attack, which is a TCP reset attack. So I'm going to show this attack on SSH first and then Telnet, and the goal of this attack is to break the connection between the server and the client. So first I'm going to go to the client machine and SSH into the server at 10.0.2.6. And then I have Wireshark open on the attacker machine to capture the most recent SSH traffic between the client machine and the server. So once I get these connections in here, I'm going to scroll down to the very bottom because I want to make sure I get the most recent packet. So I'm going to click on that packet, and then I'm going to click on the drop down menu. Alright, stop it. Now I'm going to click on the most recent packet, just expand it here so you can see it a little bit better. So when you click on the transmission control protocol, we can see the source and destination address, and then we can see the next sequence number. So I'm going to open up a Python file and put those numbers into the file. So here's my reset code attack, and so as you can see, the source is set to the server and the destination is set to the client, and so we're going to be changing the destination port, the source port, and this and the next sequence number. So first I'm changing the D port to the one that's shown on Wireshark, and now I'm going to change the sequence number to the next sequence number. And the port is 22 because it's an SSH connection. So now that I type that in, I'm going to hit save and go to the terminal to actually run the attack. Now before I run it, I'm going to chmod it first to reset the code file, and then I'm going to run the program with root. Okay, and now I'm going to actually run the file. And once I run this attack, I'm going to go back over to the client machine, and we see here that the attack is successful because the client was disconnected from the server with an error saying broken pipe. So that means that the attack was successful. So now that I showed you the TCP reset attack with SSH connections, I'm going to go back through the process again, but this time I'm going to show you what happens when I connect with a Telnet connection. So now I'm going to go back to the client machine, open up Wireshark first. So I'm going to Telnet back into the server again at 10.0.2.6. And I'm going to start Wireshark here so we can capture all those packets. And again, I'm going to go down to the most recent TCP packet and then go back to the reset code file again to make the changes to the D port, the port number, and the next sequence number. So since this is going to be a TCP packet, we're going to change the port number to 23 because it's a Telnet connection. So changing the TCP port to 23 because it's a Telnet connection, changing the D port there, And then next, I'm going to change the sequence number to the next sequence number seen on Wireshark. And once I type that in, I'm going to hit save. Okay, and now I'm going to go back to the terminal. I'm going to chmod it again, and then I'm going to run the reset code file. So now once I run this code, we're going to go back to the client machine again to see what the result is. So here is the client machine, so I'm about to hit enter and run the file. And we can see that this time the connection was closed by a foreign host. So whether it's SSH or Telnet, this attack works and it connects it, so we can see that the attack was successful. The next attack I'm going to talk about is a TCP reset attack, but on a video streaming application. So here on the right side I have the attacker machine, and on the left side here I have the victim. So on the victim we're going to open up a streaming application, which is the g00.kuroa.me. So we're going to open up that application and we're going to hit play. And so you can see when I hit play that the video starts streaming. So now on the attacker side, I'm going to come over here and type in this netwalk command, making sure that I type sudo in front of it, and then the destination host is the victim's IP address. So I hit enter and you can see that that's running, and typically this would make the video application close out and have an error right away, but for some reason on mine it's not really working entirely properly. But if I do close it out, open up Firefox again, and type in the same URL, the video won't load. So in a way the attack is somewhat successful, where if they back out and come back in, they can't stream any other videos while the attack's running. As you can see here, I hit play and nothing's loading. So the attack is successful in that when the attack is running and they open up a new application, it won't load. But typically when you run this attack, you want the attack to be able to cancel and error out a video stream that they're currently streaming, not one that they're going to stream. So we can see here now that if I cancel this and I hit refresh here, that the video will load again. So we can see that the attack was successful in breaking the connection and not allowing the victim to stream video applications while the attack was running. The next attack I'm going to demonstrate is a session hijacking attack. The goal of this attack is to get into an established connection and then have the ability to remove files from the server. So first I'm going to create a temporary file on the server, which you can see here, called secret.txt, and it's under the home/c directory. So now I'm going to go to the attacker machine and get Wireshark ready and open. And now I'm going to go over to the client machine to telnet into the server. So once the client is successfully telnet into the server, I'm going to run Wireshark on the attacker machine and capture the most recent TCP packet between the client's machine and the server's machine. So I'm going to scroll all the way down, filter it on TCP. So similar to what I did in previous attacks, I'm going to edit the parameters in the session hijack code. So this time I'm going to change the S port, the sequence number, and the acknowledgement number, which we can see here in Wireshark. And I have the source as the client IP and the destination as the server IP. And then you can see below that I'm removing the secret.txt file within the home and C directory. You can see that on the line that says data equals. So once I type in all the parameters, I'm going to go to the terminal and I'm going to chmod and then run the file. So I'm going to hit save here and then head on over to the terminal on the attacker machine. And now I'm going to run the command. And so once I run this, I'm going back over to the server to type in ls to list the files in the directory. And you can see that the secret.txt file was removed, so we can see that the attack was successful. The final attack I'm going to demonstrate is a reverse shell attack. The goal of this attack is to gain shell access to the server's machine. This will allow the attacker to actually run commands on the server's machine, who is the victim in this attack. So first I ran ifconfig here, so you can see that this is the attacker with the IP address 10.0.2.4. And I'm going to open up a second terminal to type in this command. So this command is to allow the attacker to listen on port 9090 until it's granted connection once the attack's run. So here I am telnetting on the client server, on the client machine to the server. And so while the client has this telnet connection to the server, I'm going to go over to the attacker to run Wireshark. And I'm going to capture the most recent TCP packet just like I did in the previous attack. But this time I have a different file called reverse shell code. So I'm going to change the S port to the sequence number and the acknowledgement number again. But you can see in this file that there is a different line of code than the previous attack. In this code, the data equals a line of code that has the attacker's IP address in it, the .5. The .4 is the attacker's IP address. And this line of code causes the output of the shell to be redirected to the TCP connection of the attacker on port 9090 once the attack is run. And we can see that the IP source is the client and the destination is the server. So once I finish typing in the acknowledgement number, I'm going to hit save. And then I'm going to chmod the reverse shellcode file, and then I'm going to run the file in the terminal separate from the terminal where I have the 9090 command. We want to keep that terminal separate, so once we run the file, we'll see that the connection's established in the second terminal. So here I'm running the attack. And there we go, and now I'm going to switch to the other terminal, and you can see that it says connection from 10.0.2.6, which is the server's IP, so the attack was successful. And usually you'll see the Sebastian Natalie in the command line. We don't see it here, but I can still type in command and it works, showing me that the internet IP address is the server's and that the attack was successful.